final lesson in Chapter 3 involves solving systems of equations that have 3 variables as opposed to the 2 we started our unit off with. As I look at this first system of 5x plus 4y minus z equal to 0, 10y minus 3z equal to 11, and 3z equal to 9, the first thing that strikes my notice is this 3z equal to 9. And the reason why is simply because we can solve that and already know what z is. So I will take that 3z equal to 9, divide both sides by 3, and get that z equals 3. I will then take that and head over to the 10y minus 3z equal to 11, because I can take that now and substitute in my z equal to 3 to get 10y minus 3 times 3 equal to 11, which is 10y minus 9 equal to 11. Add 9 to both sides to get 10y equal to 20. Divide both sides by 10 to get y equals 2. Substitute it in to the 5x plus 4y minus z equal to 0 to get my final solution for x, and therefore my ordered triple that we need for the problem. So 5x plus 4 times our y value of 2 minus our z value of 3 should equal 0. 5x plus 8 minus 3 equal to 0. 5x plus 5 is equal to 0. Subtract 5 from both sides. 5x equals negative 5. Divide both sides by 5 and we get x equals negative 1. Now that means my final solution is going to be written in the form of x, y, z, which in our case is x equals negative 1, y equals 2, and z equals 3. So this negative 1, 2, 3 would be my final solution. Moving on to B. B is a little bit more involved simply because we have all 3 of the equations within the system that have all 3 variables. So we cannot simply solve for one, substitute it in, solve for the next one, substitute it in, and get the third one. So we want to use elimination. And when I look here, I immediately notice that if I start by combining or adding equations 1 and 2, I'm going to eliminate z. So if I do that and I add those 2 equations together, I get 3x plus 3y, 12. Now, because I've eliminated z, I want to eliminate z in another one to create a new equation. So if you're taking notes over in this right-hand margin, under step 1, you're going to write that you will eliminate one variable by adding 2 of the equations. And then step 2, to eliminate the same variable by adding two different equations. When I look here, I see that my next two best bets are going to be equations 2 and 3, because I want to get rid of z, and z is already negative in equation 2. So I'm going to write down to add equations 2 and 3. So I'm going to do that by multiplying the second equation by 3, so that way I have negative 3z and 3z. So I'm going to write down 2x plus y minus z equal to 4, and we're going to multiply that by 3, which gives me 6x plus 3y minus 3z equal to 12. And when I add that to x plus y plus 3z equal to 7, I get that 7x plus 4y equals 19, since these cancel. So now I have two new equations. So I want to now use those two new equations to eliminate a variable, and I'm going to choose to eliminate y, because 3 and 4 work much better together than 3 and 7, because that makes them for some bigger numbers. So step 3 here, I'm going to use the two new equations to eliminate y. So I have now 3x plus 3y equal to 12, and 7x plus 4y equal to 19. I'm going to take and multiply the top equation by negative 4 and the bottom equation by 3, which gives me two new equations of negative 12x minus 12y equal to negative 48. And then the bottom equation will be 21x plus 12y equal to 57. So when I add those two equations together, I get 9x equals 9. So when I divide by 9 on both sides, I get x equals 1. Now, my final, I get x equals, so now what I want to do is to take my x value and we're going to substitute it into one of the new equations to solve for y. So I'm going to use my 3x plus 3y equal to 12. So I'm going to write down one new equation and substitute x in to solve for y. So I use 3x plus 3y equal to 12, and I'll put in 1 for x, so 3 times 1 plus 3y equal to 12. So that's 3 plus 3y equal to 12. I subtract 3 from both sides, and that gives me 3y equals 9. Divide by 3 on both sides, and I get y equal to 3. So now I've got two of my variables. So now my final step is going to be to substitute into one of the original equations to get my z value. So now I'm going to choose from my original equations, if I go back up to the top here, I want to use the last one because x and y are already coefficients of 1, which means my numbers are going to stay small. So I'm going to go back down here, x plus y plus 3z equal to 7. And in there I'm going to substitute in my x value of 1, my y value of 3, and then I have plus 3z equal to 7. So that's 4 plus 3z equal to 7. Subtract 4 from both sides. I get 3z equals 3. Divide both sides by 3. I get z equals 1, which means my final solution is 1, 3, 1. Now in the next video, we'll show you one more example.